right, welcome to week 6, day 2. We've just finished up classes. We're just kind of adding a few more topics in here before we switch to web and looking at the front end. Right now, we are going to be touching on data structures today. And again, it's going to be another pretty from the README lecture today, but I will also kind of help you figure out where these data structures exist in real life. Because we're going to be touching on, I think, 3 main data structures here. So we're familiar with some basic data structures, right? And it says it here, we've got lists and arrays, dictionaries, objects. We are used to those types of data structures. We're even somewhat familiar with stacks because we've done recursion and we talked about how there's a recursive stack. And even though we're not like 100% on what that is, we know it exists. So it's just yet another data structure. There are so many more other data structures, though, besides just lists and dictionaries. And we're going to look at 3 common ones today that you'll see. And these are not always going to be in a library or in a way that's usable for you. You sometimes have to write your own version of this data structure. And that's kind of what we're going to be working on today. So let me pull up my VS Code here. The first one we're going to be looking at today is called a stack. And this is the one I said that you've already kind of had a little bit of intro to already because we've done recursion. Recursion works on a stack. I like this picture. Let me pull this picture up and over to the other side if I can. So looking at it's tiny, hard to see. There we go. Okay, so a stack, think of it like a stack of blocks. Anytime you add something to this structure, it goes on top of the last one. So it keeps going on top, on top, on top until it stacks all the way up. When you're ready to go ahead and start taking off the stack or pulling data out of the stack, it comes off from the top because we've stacked it up. So it is last in, first out is how we refer to this. So you stack up data in here and then you start pulling off from the top as you work your way back out. Records are always added to the top of the stack, and then records are always removed from the top as well. So you can see that in the README. I said last in, first out. This also means that stacks only have one access point. You can only access it at basically the top of this data structure. There's no other way to get information from this. So I can't like reach down and grab the first item in this stack. I have to take the last one that was put on or available for us. So stacks at a minimum have the following. Well, let's get this code up in here too, and we could talk through this. This is in the README. This is making our own stack using classes like we're familiar with now. We have our initialization method here, and at a minimum, a stack has these 3 features to it. A push, which is where we add an item to the top of our stack. A pop, which is where we take the last item off the stack and return that item. And then a peek is going to be just returning the value of what's on the top of the stack. So we're not removing it off, we're just looking at that value. So first thing we need to figure out is what kind of data type we can be pushing into and popping off of for our stack. What sounds like a pretty easy data type that we already know and work with? That would be a good thing to put things into and take off.
A list?
List.
Yep, I like a list. Dictionary is a little bit more difficult than we're looking for here with our key value pairs, but a list for sure. We know we can append and we can pop, we can do all this stuff to a list. So for our initialization method, we're going to decide this stack is going to live in a list. We're going to call this the base. This is the base of our stack where everything's going to go into empty list. So when I initialize a stack, it'll have an empty list. Perfect. So now we've said when we add to a stack, it should go. Okay, so our list is going to be lengthwise, but we could basically look at it like flipped vertically as well, right? So basically, we want to be adding things into our list, and then we'll remove from the end backwards. Okay, so let's think of that when we're thinking our push. We want this function to be able to add things to our list after things that already exist in our list. So what would be a good built-in Python method that we already know about that adds things to this list in order? So if I wanted to put something in here, how can I put it in? What's one of the ways I could put it in?
You can append it.
Append it, yes. Is this a good option for us? What does append do? If I have a few things in here and I append to this, where is it going to go?
At the end.
Perfect. And that's what we want, right? We want to add at the end because we're going to keep going in order. Nothing's getting put in earlier. It's all going to add to the end. So let's go ahead and make a method to go to the base and append just an item. Okay, because we got to pass in. So let's pass that in here in our parameters. We're going to give this an item that we're going to put in our stack. Okay, so if I give it the number 1, I want this function to, or this method to put number 1 in our list, which it will here. And it will keep doing that, adding one right after another. So now, how can I remove the very last thing of this list?
Dot pop.
Yes, pop. It's in the name. We're going to use Python's pop. And that will remove the last item and return it. So, well, it's not returning it yet, but how can we return it?
Oh, place return in front of it.
Yeah, we can just return the pop. So now whenever I run this method, do I need to pass anything into this? All I want this method to do is to take out the last item of the list. So no, we don't need to add anything in here. And now once I run it, it will automatically just return the value of that last item taken out of the list. It's removing it from the list and giving us that item. Now, peek, we want it also to give us the value of the last item in the list, but we don't want to take it out of the list. We just want to look at it. So how can we just give us the value of the last item in the list?
Are you saying like if it was an integer, what the value of that is?
Yeah, or anything. If I had several things in this list, how would I target? It could be like we're getting fancy here. So I mean, this could be my list. Where did it go wrong? Pam doesn't have it. So how can I grab the last value in this list?
You need to. Oh, sorry, Cisco. You want to go?
Go ahead.
Um, make a for loop to iterate through the list.
I could. Is there maybe a shorthand way to just identify the last value in list? Do we remember how to target that?
In the brackets, just put a A -1.
Yes, negative one or the -1 will automatically give you the end of the list value. That's the end of the list index, basically. So we have 0, 1, 2. But if we do a -1, it's always going to return the last item. So that sounds great, but what happens if the list is empty and I tell it to return, like, right, we want to return self.base -1. But what if the list is empty? This is going to mess up, right?
You're gonna get an index out of range.
Yep. So we got to handle that. Let's add an if statement. So how can we check if this is empty or not? Because basically,
If
oh,
if self dot base if len parentheses self dot base equals 0 or something like that equals 0.
then let's just return none. Okay. Otherwise, we'll return the last value. Sounds good. Could also, in the README, it says if self.base. So basically, if there's stuff in it, go ahead and return this value. But we went ahead with if this length is nothing, we'll go ahead and return none. So there's nothing in there. So this is a stack. This is a data structure for a stack. So where do we use this? Like when I was doing this lecture, reading through it, I'm like, these are great. These are great data structures, but y'all have no idea where to use these probably. Can anybody think of a way, like what would be a good use of a stack? It's something where when I add items into this, it'll keep stacking up. And then when I remove items from it, it gives me the last one first. Any ideas whatsoever? And I don't blame you if you don't have anything coming up.
Mimicking a top loaded dish rack or something, where you put each plate in one at a time, and the plate on the bottom is going to be the bottom of the stack, and you have the plate on the top, which is going to be the top of the stack.
Yeah. So that's a good real life example, putting dishes and then taking off. And then that's how the recursion thing went too, right? We saw in our little debugger that it was adding stacks as it's holding that recursive thing. Then when it gets to the end, that base case, then it starts on taking those stacks back off. I'm thinking more programmatically. A good example of an actual use case for a stack is your browser history. So anytime you navigate to a page, each page is pushed into a list and it's held there. But when you hit the back button, it pops off the page you're on and goes back to the last page you visited. So, and then if you push back again, it go back again in that list. That's the way where it's adding, web pages in a row. And then when you push that back button, it's targeting that last value in the list and working its backwards. So that is one real life example of using a stack in programming in your development. Probably won't do that because our libraries have built-in methods for that. But like browser router is built into React and handles all that for us. But that's just a use case of where that type of data structure is actually used. And that was all I could really find that was worthwhile discussing. A lot of the rest of it was just examples of plates and well, it had recursive function calls too. That was a good one. Undo feature in like your Word documents. If you push undo, even here, if I Control Z, that's going back to the last thing that happened. So it's stacking up every action I do. Albeit this undo probably doesn't pop it. If it does, it puts it somewhere else because we also have the redo function, right? So it's going backwards, but all right, yep, that's a good example of a stack. Any questions on stack before we move on to the next data type? So next one we're going to work on now is a queue. So if you think of a queue like a line waiting at the DMV, you know, you're in queue. What does that kind of tell you about the order of this data structure?
First to last.
First to last, yes. So the first item in is also going to be the first one out of this data structure because it's a queue. It wants to keep things in order so that nobody's cutting the line or getting ahead of it. And we have in the README, nice little picture. When you're end queuing items, you're adding it to this line. It's still going, you know, one right after another. But when you're taking things out of this queue or dequeuing items, you take from the first one that was added. So we are, I guess we could, no, we're not going to do this because this is part of your assignment today. But you, with a queue, you could approach it just like we did this stack. You have your initialization that's going to have a base that holds our queue, probably a list. And it's going to have three different methods. It's going to have an end queue, which adds an item to the beginning. It shouldn't say to the beginning. That's confusing. It adds an item. Insert from the bottom and remove from the top. First in, first out. Yeah, okay. So yeah, is that confusing to anybody or just me? You're supposed to add in order, right? When you're end queuing items, you're adding in order. You're not throwing an item to the beginning. So you're adding in order. Then the dequeue, you remove from the end, or well, in our case, the beginning. This is very confusing terminology here. Look at the picture. That's all you need to do. For dequeue, you're going to take from the beginning of that data and remove that. Okay, so with our pop, if we were looking at this, a stack would, you know, build it up just like this, 1, 2, 3, 4, 5 in a row, but then the stack would have taken off from the end here. But in a queue, we build it up, you know, one right after another, but we take off the front of the list instead of the back. So we wouldn't pop things off, we would do something else because we need to target the first item in the list. And remove that out. And peek, same thing as same idea as this, is we are giving just the value of that first item currently at the beginning of this queue. Okay, any questions on the queue? Now it's kind of easy to follow. It's like I said, it's like a line waiting at the DMV. Real life examples is your print queue. Anytime you push print and add items to that queue, you know, the first thing you've got in there is going to be the first thing printed and so on. And it works its way through the list. So that's a queue. Yep, that's about it I have for that real life example. All right, now the last one. This one's going to be the most difficult and weird to understand. Linked lists. So the stacks and queues are simple data structures, but linked lists are a little bit more complex because it's composed of nodes. And each node has two properties. It has its value and then a reference to the next node. So you can see this is data and next. This means this is its value. And then this is actually going to be a reference to the next node that it connects to. So this one we will do together, it looks like. So let's go ahead and pull that off to the side. I think we'll give the real life example before we work on this because linked lists are kind of hard to wrap your head around with this whole, node connecting to another thing. So one example it has is playlist of songs where you could skip forward to the next song. So each song you're currently on, like in Spotify, you can see like what's playing now, and then you can see the next song, right? So that's an example of a linked list where you have your song currently playing and then the next one in line. You've got both values there because it could see the next one it's linked to, and then you're able to traverse to the next node, which is the next song in the list. So linked list should have two methods. Now, this is probably throwing some people off in the README if you're following along, but it will say in the following API. So APIs we will learn later in class, but this is just a method we could use that returns data for us. We'll keep it at that for now. So when we're talking about the following API, we just mean this class that we can create and use for our data. So each linked list should have an insert that adds an item to the beginning or end, depending on implementation, I guess, and then a search, which traverses the list and returns the appropriate node if found. So if you're looking through a playlist, it's going through each song in that playlist that's like linked to one another, and then finding it based on that way. Let's see. So first we'll create a node class. And pull this straight from our README. Here we have our class node, and this is the initialization method. Now we're passing in a value. And you can see that it initializes with a value, and then it has a next, which is equal to none. So we're going to have, this is a node, and we were talking about our linked list is nodes hooked together, right? And each node has two properties, which are here. So this node has two properties. It has its own value and then the value of the next thing after it. Looking back at this is the node, the current data, and then the value after it. So when we set up a node, if there's nothing, cross these out. We don't see these, okay? Let's say those don't exist. Oh, it's not going to do it. If we're just looking at one node, you'll have data existing, but you won't have anything next because we haven't added anything to our linked list, right? So that's why we have the next is going to be none. It's going to be empty. Because now we'll have to do our implementation of the linked list where we insert a node and then we'll search through the nodes. So the next thing we're going to work on is inserting our second node, which when we insert this node, we're also going to have to change the value of the node it's attached to, right? Because now it will have a next. So let's go ahead and grab this linked list and start messing with this. Okay. So with our initialization method, there's only one way to traverse the linked list. So we need a starting point. So our starting point is just going to be the head of the list. We don't have any nodes yet. It's nothing, basically, right? We don't have anything when we start off. It's going to be empty. So we're going to have a head of this list, and it's going to have nothing in it. But then when we add an item, we're going to want that to be basically the head, right? Because when we add a node, we're going to add a node now. We will put it in place of this non-existent head. We're going to replace it. Okay, so we're going to have, whenever we insert, we're going to have a node created. All right, so let's just work on that first. We're going to create a node. So we'll call this new node. We're creating a new node, and it's going to be an instance of a node class that we've defined up here. Okay. And it's going to, so node expects a value. In this insert, we're passing in a value. So I'm going to go ahead and plug that in here. So now when I run this insert method, it will take whatever we put in as the value and make a new node that has a value and then a none for next. Okay, so I've made a new node. Now I need to place the node in my linked list. And I don't want this head to be none, right? We want it to have a node. So when I place this node, I'm going to say this old node is going to equal the start of our linked list. Okay, so I'm targeting this old node. There's not one there right now, but it has a value. It has a none value. So I'm targeting it here. Now I'm going to say, take that head and make that my new node. Okay, I'm reassigning the value here. So I've got, now the head is going to be my new node that I created here when I said insert this new node. So I'm almost done. Okay, so I have, this one is going backwards. We're okay, yeah. So with this example, we're inserting at the beginning of the linked list. You can insert at the beginning or the end. So let's look at this now. So we made a new node that's just kind of hanging out there, right? And then we said, I want, and we've identified our old node as this self.head because it's empty. And this new node I'm putting in as the head. So now the new node has a value, and then it has my next equal to none because it's not linked to anything yet. But here we're going to link it to our head node because we are putting it in the front. I guess we're not replacing it. Sorry, we're not replacing it, but we're linking it. My terminology was bad. So we are keeping the head. We're not replacing the head. We're keeping the head. We're inserting this other one in front of the head. Are my hands backwards in the presenting? I don't know if I'm going the right way. My hands. So in order to do that, we had to kind of make where we're currently on the new node. And then we're going to hook up the next in line is going to be what our old node is because we're going backwards from the beginning, if that makes sense. Let's see if I could, okay, let me pull up this picture. With this, we're basically saying this is the head. Or, well, this is, our head is none. When we insert a new node, we're trying to basically keep none here, put our new node here, and then tell the new node that the next is equal to the head or the old node. So that's why we have a new node and an old node, because we're saying our old node is here. We're inserting a new node here. And then now I need to say our next for this new node is going to be the old node. Are we following? Are we sort of? It's weird. We're going backwards because each of these nodes has two values. It has its value and then it has pointing to the next node. So let's keep, I'm gonna do, let's go half and half here so we can see. Okay, so right now we had our new node. We created a new node here. And we said our old node was this head node, which was set to none. So we're pretending this was the head node set to none. Then we said, now set this head node to the new node. Bizarre. And then now we're going to follow up with the last part, which is we're going to set the head dot next to the old node. Okay, because we said this is now the head of our linked list. This was the head, but now this is the head. But we still have to link it to what the next item in this linked list was. So now we're going to say self.head because we've reassigned it. Our new node is now the head. Our self.head.next, because we need to give this a value, doesn't have one, doesn't come automatically with value assigned, is going to equal the old node. Because our next is pointing to the old node. So this is kind of a trippy brain processing here because we're going backwards. It's really weird. I think when you do your assignment, you're going to be going forward. So let's see if this works with this next one too. Let's say, so I have now this 2, but node 2 is my head after we ran this insert. Okay. We had none was our old head when we initialized this, but now 2 is my current head because we told it was the current head. Now I want to insert another one. I want to insert 1. So if I insert 1, it makes a new node, which it's going to do right here. It makes a new node 1. And now we're going to say the old node is the head. What's the head? What did we say is now the head? I had none was the first head, 2 was the new head after we inserted. So if I'm making a node 1 and I'm saying the old node is the head, what is the head at this point? 1, 2, or none?
It'll be 1.
No, Adam was right. It's 2. You're getting ahead of me, I think, Cisco. So the old
My
node,
bad.
the old node is equal to what is currently our head, which is 2. Because the last time we inserted in this linked list, we told it this was the head. So now this is our new node that we made. This is going to be old node, the head. Now we're getting tricky here and we're saying now the head is going to be the new node. So at that point, we're saying, okay, now the head is 1 at that part. So I think that's where you were at, Cisco, is this line.
Yep.
Yep. So now the new node is the head. So now this is called the head. We've got 1, but next is empty, right? Because when we initialize a node, we pass in the value, but next is empty. So we have to tell it next is going to be that last node we were just on. And how do we target that? By saying old node, because we told it back then, before we switched out and reassigned the value of head, we said the old node is what head was. Okay, so that's how we do the next now. Next is targeting the old node. And it just keeps repeating that process. So this is head now, and then you make a new node, and then the old node will be the head, and then the head becomes the new node. I see the confusion. Why do they have one twice here? That's weird. Okay. Kind of hard to step through and wrap your brain around, but try to spend a few minutes when you're working on the assignment, kind of looking through how this is working. It's assigning nodes to a new variable name, okay? So don't get caught up on, oh, head's here, but now it's here. No, these are all the variable names. These are just the values, the nodes that we're putting into these variables. Okay, so we have a head, we insert a new node, the head becomes the old node, the new node now becomes the head, and then we attach next to the old node, and it keeps doing that. Okay, whew. Now we'll go on to search. So, oh gosh, they didn't do it for us. Search could be implemented either iteratively or recursively. Let me look at the assignment today. Okay, yeah, it wants you to do that there. So sorry. Not really. In either case, a search will have to start at the head. So we have a head for this linked list, which gets new values every time you insert something, but it's still the head, right? It's always going to be the head, no matter what its value is. And you'll start at that head at that time and continue until either the appropriate node is found or the end of the linked list is reached. So remember, when searching, so in this weird backwards addition that we're doing, kind of weird to think about, but if you start at the head, you'll have to, well, the head will be at the end of whatever one you inserted. The head's going to be down here, right? Because if we insert, that becomes the new head. So it's going to start at the head, and then it will look at the next node value. So if I was at the head, if I did head.next, that will give me the next node's value. So if I did, this is a bad example. Let's say this is the head. If I did this head.next, it would give me 2. Okay, because it's linked to this value. So the search feature would start here and say pretty much if you wanted to do it iteratively, you'd, for each node in this list, or we'd probably have to do a different type of loop. I'll take a minute to think about this, but you'd look through each node, you'd be on the current node, and then you'd look at the next value, and then you'd also have to go to that node and then look at the next value of that node, and then bump up to the next one. So you do reassignment just like this. You'd have an old node, which is the head you're on, and then you'd look at the next node. Okay. It's okay if this one isn't as strong of a concept. It's a little easier adding in a row instead of backwards because you don't have to do kind of this crazy weird backwards reassignment. If you started at the head and you inserted a node, you would simply say the new node, the head is now the new node, right? Oops, you got to move it along. So this would become the head. And then the next would be whatever you inserted after that, which is to be determined. Maybe that would be a little more difficult. All right, we're not gonna go down that rabbit hole. Any questions on stacks or queues or even linked lists? I'm sure there's lots of questions on linked lists, but no. Okay,
Uh,
I will. Oh, go ahead.
I was gonna say, I think I just need to go and try to apply it.
Yeah, for sure. I think once you start working with the linked list and putting actual values in, um, it would be easier than just kind of trying to imagine this. Pictures help me, so that's why I was kept referring back to here. Um, but it will definitely come a bit easier with practice, which you're going to do in a second. Any other questions before I stop recording?